Alright, here we're looking at section 9.6, and our learning targets for today are to solve systems of non-linear equations by graphing. So we've looked in the past at systems of linear equations where both of our systems were lines. Now remember that a system of equations is where I have more than one equation that I'm trying to trying to solve together. So here at least one of my equations is not going to be a line. So first we're going to be doing that by graphing them. Then secondly, we're going to be solving those systems algebraically using math, and then we're going to approximate some solutions of nonlinear systems and equations. So the first thing we remember that when we have a solution, it's where my graphs intersect or my equations intersect. So when one is linear and one is not, as shown here, I have a quadratic and a line, there is a possibility for no solutions, right? They don't have to touch. There's also a possibility of one solution and a possibility of two solutions. So those are our three different things that we can be looking for. So the first thing we want to do is solve this system by graphing. So I'm given my two equations. One of them, this top one you'll see, is quadratic. The second one is linear. So this is my nonlinear system here. So the first thing I want to do is graph each equation. So I can use my graphing calculator or I can use Desmos and graph both of them. So I just graph them separately and they come up on the same line. I can see here that they intersect at this point at -1, -4. So I want to estimate that because it looks like they cross there. So now that I've estimated this point, this -1, -4, because it's what it looks like based on the graph, I go ahead and I plug those values back into both of my equations to see if they work. And remember that x is always my first term and y is always my second one, so I plug in anywhere I see an x in both equations, that -1, and anywhere I see a y, that -4. And I do the math and I just check, and it worked. So my solution is -1, -4. And here it appears I only have that one solution, right? Just because of where this line and the quadratic lie. It would be possible to have more than one solution, and we will see some examples of those. So now here are a couple that I want you to try. You can definitely use these when you're graphing them. Use either your graphing calculator or use Desmos. Either one will work. So now we're going to be doing some solving by using algebra. Okay, we're going to look at the second learning target, which is solving systems algebraically. And remember, there were two different ways that we could solve systems of linear equations. We could either use substitution or we could use elimination. We're going to look at both with these nonlinear systems as well. So this first one we're going to be using substitution. So I see I have a quadratic equation and a linear equation. The first thing I see is that they've both already been solved for y. So they're both y equals and y equals. So since they're that way, I can substitute in this -2x plus 3 in my top equation for y, and then solve for my x. So I end up with my -2x plus 3 equals x squared plus x minus 1. So I've substituted in that value that I knew for what I had in my original equation. So now I can just solve for x. So I add 2x to both sides, and then I subtract 3 from both sides. So because I'm dealing with a quadratic, remember I always want to get everything to one side of the equation. So now that I've done that, I've gotten everything to one side of the equation, I can solve this quadratic. And when I solve a quadratic, I can either factor, or I can use square roots, or I can complete the square, or I can use a quadratic formula, whichever one is easiest. So here I see that this one is pretty easily factorable because my a value was 1, and I know the factors pretty easily of this -4. So I factor out my polynomial, and I set both pieces equal to 0, which is my zero product property, and I solve for x. So now I have two possibilities for x. So now I substitute those both into the second equation to solve for y. And here I'm just using the second equation because it's easier. I could substitute those x's into my top equation, but that just involves a little bit more math. So I'm going to use a second equation because it's easier. So I substitute those in, and I solve, and I simplify. So I end up with two solutions here. I have -4, 11, and 1, 1. So this is an example where I would have two solutions. And I can check that by graphing. So I could graph this on Desmos after I've solved this and see that yes, I do have two solutions, two places where these graphs intersect or cross. So I know I was right. So now here we're going to be looking at elimination. Elimination is that other way that we can solve some systems of equations, right? So I don't have anything out here with the y's, right? It's y equals and y equals. I don't have to multiply either equation by a constant, so I can leave that alone. If I had different values here, I would have to get those to be the same, but I don't have to since they already are the same. So now I want to subtract this second equation from the first equation. So first I want to line them up, right? So I have all of my x squared terms in line, all of my x terms in line, and all of my constants in line. Well, so now that I'm subtracting, I've got my y minus y is 0 equals x squared minus 0 is x squared, negative 3x minus a negative 3x, so it changes the sign here, so that goes away. Negative 2 minus negative 8 gives me a positive 6. So now I've subtracted them, and I've got myself a nice quadratic. So now I can solve for x. So what I do is I see that I don't have an x term, I just have x squared. So I'm going to subtract 6 from both sides, and then I can take the square root. Except here I end up with x squared equals a negative. And remember, I can't have any negatives when I'm taking the square root, so I have no real solutions for this one. Okay, if ever we end up with a negative over here that I'm trying to take the square root of, that's where I have no real solutions. And remember, that can happen if my graphs don't touch at all. So again, I can check this using a graphing calculator. So I see I have my line and my quadratic, and they don't ever touch, so I know I was right in my math. So now here's a couple I want you to try. I want you to kind of get comfortable looking at both substitution and elimination, because sometimes one will be easier than the other, and it's useful to know both strategies. So now here's our last learning target. We're going to be approximating the solution to the system to the nearest thousandth. So here you see I have a quadratic and I have an exponential, right? I don't have a linear equation at all to deal with. I just have a quadratic and an exponential. So it makes it a little bit more difficult because we really haven't dealt with too many exponential equations yet. So here I want to kind of use some approximation methods. So the first thing I do is I sketch my graph, right? And I graph it using Desmos or my graphing calculator. So I can see here that I have a solution somewhere between 1 and 2, right? And I see that it's also closer to 1 than it is to 2. So I know I'm going to be dealing with some numbers down here closer to 1. Okay. So now I'm going to substitute this 3 to the x for y in my first equation and rewrite my equation. So then I can rewrite it where everything is on one side, set equal to 0. Okay, so now I don't know how to do this algebraically. I want us to just start picking some numbers and trying them. So I picked 1.1, right? Because I noticed that this was closer to 1 than 2. We're going to start down here closer to 1. So I've got 1.1, and I plug this in and use my calculator, and I get this negative 0.26. So then I try the next one, is 1.2. And I get approximately 0.02. Well, here I see I have a sign change, right? I went from negative to positive. So that tells me that my solution to this system is in between 1.1 and 1.2. But I also see that 1.2 is closer to 0, so I know it's closer to 1.2 than it is to 1.1. Okay, so now I'm going to continue to evaluate. I'm really just adding the next decimal place, right? Because this could be, this 1.2 is the same thing as 1.20, so it's like 20. So I'm going to decrease a little bit and try this 1.19. So I try that in my calculator, and it's negative again, right? So I went from a positive here at this 1.2 to a 1.19. So I've switched signs. So since I've switched signs here, I know that my solution is in between those two. And again, it's closer to this 1.2 than the it's closer to the 1.19 than it is to the 1.2. So I'm going to add this hundredths place into my calculations. So now I'm going to try this in my calculator. And since it's still negative, I just increase my guess a little bit every time. So now that I've changed signs again, right, I see I went from a negative 0.0002 to a positive value. Now I know that I'm close enough to my solution that I can approximate it. But I know that I'm going to use this 1.194 value rather than the 1.195 because this number is much closer to 0. So I'm going to approximate my solution at x equals 1.194. So now that I have that approximation, I go ahead and I substitute that into one of my original equations, whichever one you're more comfortable working with, and solve. So I end up with 3.713. So the solution to my system is approximately 1.194, 3.713. So the things we really looked at when we're approximating these solutions is the change in sign. When my sign changes, that tells me that's where my solution is. And then I just continue to narrow my grid, narrow the things that I'm looking at in order to find that solution. So now here's our next example. And again, I see I have an exponential and I have a quadratic, but they're set equal. So I can set each side equal to y because I don't know how to do this algebraically. There's too many variables and too many exponents. So I use each side to write my own system. So y equals negative 2 times 4 to the x plus 3, and y equals 0.5x squared minus 2x. So now I can go ahead and use my graphing calculator and graph them, or I can use Desmos and find the intersection points. Now, when I'm using a graphing calculator, I can actually use the intersection feature. When I'm using Desmos, if I click close to where the intersection is, it will actually pop up for me, so I can find both of my solutions here. And again, when we're looking at the graph, make sure you can see anywhere that the graphs might intersect so you don't miss a possible solution. So one of my intersection points is -1, 2.5, and then the other is 0.47, comma negative 0.83. So those are my solutions. So I can also use a graphing calculator using this table feature to create a table of values and then find the x values where my y's are approximately equal. This takes quite a bit more time and more work when we're dealing with these calculators and figuring out how to set this up. If you ever want to go through how you can do this in your calculator, please come see me. But we end up with the same values, so my solutions are the same either way. I would definitely advise when we're using our technology to go ahead and graph them and use the features that are available to you that way to help you solve these systems. So now here's the last couple of problems I want you to try. You know, you're always given in your equation how you are supposed to round your solution, right? So here when we're approximating, we're going to round to the nearest thousandth. So I know I need to go to 3 decimal places. Here I'm rounding to the hundredth, so 2 decimal places. So keep this in mind when you're solving these and approximating, that you're rounding to the correct value. So now we're going to look at our learning targets again, just to make sure we got them all. So first we were to solve systems of nonlinear equations by graphing, and we want to really go ahead and use Desmos for these, so we can graph them and see where they intersect. Then we were to solve them algebraically. So to do this, we used both substitution and elimination. So we're really going to be doing this when I have a quadratic and a linear function. If I ever have any exponential functions, I'm going to go ahead and use my graphing calculator or Desmos to help me do that. And then our third learning target was to approximate solutions of those systems and equations. So when I approximate them, I kind of figure out, I just start substituting in numbers that I think are close and continue to dig down until I get to the most close number I can. So now that we've gone through these learning targets, go ahead and work on your homework for 9.6.